Good evening, everyone. We are going to start this month webinar conducted by Institute of Physics Sri Lanka. I am C.A.Thotawatthage, the president of Institute of Physics Sri Lanka. First of all, I would like to warmly welcome all the participants of this webinar too. The main objective of the IPSL is to promote and advance the science of physics in Sri Lanka. Thank you for making the time today also. So today's resource person is Dr. C.A.Thotawatthage from the Rajarata University to talk on how to do innovative research. Dr. Thotawatthage, thank you very much for accepting our invitation. So before formally begin the presentation, let me call upon Dr. C.A.Thotawatthage Nupayarachchi, convener of this webinar and the editor of the IPSL, to introduce today's resource person. Thank you very much, and over to Dr. C.A.Thotawatthage.
Thank you so much, sir. First of all, I would like to give a brief introduction about the speaker today. Dr. C.A.Thotawatthage is a temporary senior lecturer in the Department of Physics at Faculty of Applied Sciences, Rajarata University of Sri Lanka. He completed his BSc degree in Applied Sciences with Physics and Mathematics with major subjects at the University of Peradeniya in 2007, and he completed his MSc in Computer Science at Postgraduate Institute of Science in University of Peradeniya back in 2013. He completed his PhD in Physics at the same institute in 2018, and he has worked as a research assistant at the National Institute of Fundamental Studies from 2007 to 2018, and then become a junior research fellow in 2019. His research is focused on nanostructural modification to photoanodes and electrolytes to improve the performance of dye-sensitized solar cells. Apart from that, he is keen to do research on batteries and electrochromic displays. His collaborative research work is going on with Chalmers University, Sweden, University of Malaya in Malaysia, and he got 22 international publications along with the other publication. His number is 57, and he has an H index of 14, and he has got Presidential Award for Scientific Publication in 2014, and also NRC Merit Award for Scientific Publication in 2011, 12, 16, and 21. So without taking much time, I would like to hand over the platform to Dr. C.A.Thotawatthage. Over to you, sir.
Thank you. So thank you for the warm welcome, Professor Sanath Gamage, and thank you for Dr. C.A.Thotawatthage Nupayarachchi for inviting me for this webinar series. So today my topic is how to do an innovative research work. So I think you can see me and hear well.
Yes.
Right. So what is research? So it is a careful study of a subject, especially in order to discover few facts or information about it. So that's from Oxford Dictionary. So simply I can say it's searching for knowledge and searching for truth. So in my today lecture, I will going to talk about what are the type of research and what are the criteria for the good research and what are the steps for the research, and going to share my some personal experience. So the type of research we can divide it into 4. So the first one is the basic research. In that we are aiming at explain limits of knowledge and not giving any solution to specific problem. So for example, how did the life began on Earth? So we know there are two theories. Life came from extraterrestrial, or life was on the Earth, and it's the two theories. But nowadays we think that both these happen, and most of research going on those topics, but still we are not exactly know how that life is begun on Earth. So the second one is applied research. It's a aim on solving currently facing problem. For example, how to improve agricultural crop production using carbonic fertilizer. So it's a hot topic in Sri Lanka nowadays. So there are a lot of research going on, and that kind of research is categorized under applied research. Third one is the quantitative research. So it's investigation of quantitative properties, phenomena, and their relationship by asking narrow questions, collecting numerical data, and analyzing its utilizing statistical method. So for example, when we take some work or service from any service provider, so let's say mobile service provider, they send a SMS message and ask whether we are satisfied or not. So that kind of thing, gathering information. So it's a conducting a custom satisfaction survey. So likewise, they categorize under quantitative research. So the final one is qualitative research. So in there, the research refers much more subjective and use different method and techniques to collect data and analyze, interpret, and meaning and definition characteristic. So in that quantitative research, we can subcategorize into three. The first one is phenomenology. The second one is ethnography. The third one is case study. In first one, it's a very powerful and strategically demonstrating methodology for a health sector. So for example, in a corona pandemic situation, we doesn't know that kind of thing before, and it's suddenly happened, and we have to find for a cure. So in that case, a lot of research going on about the newly found that virus, and they mainly focus on find a vaccine for the corona. The ethnography, it's a mainly focus on a cultural thing. So we can do some research on a group of people, and so we can gather their attributes and learn their language and how they live in the surroundings and what are the relationship with them. So for example, a researcher might decide to go and live with the tribe in Amazon jungle and study the culture and their lifestyle. So there are few peoples in Amazon jungle. So they are very far from the normal civilization. So they have different lifestyle, and so we have research on them, and we have to learn how they talk each other and how they live in the jungle, and they have a different thinkings, and they may sometimes have different kind of food preferences likewise. So we have to research on them. So case study is different from both two. So it's a very complex one, and it's mainly based on one person. So, for example, a road rail employer who experienced an accident, and the metal rod is passing through his skull. So, not happen every day, and not happen to every person, but it's a specific one person. So we can get some data, or gathering some information from him. So after the person recovered, and we can study his behavior, so it can change with the previous his lifestyle likewise. So we can get some information. So that one we can say a case study. So let us move to the next one. So criteria for the good research. So there are some several factors. The first one is purposiveness. Research, it should be a meaningful one. So to get meaningful result, the scientific research must have some specific purpose to conduct the research. And the second one is the testability. To then to meaningful research, we have to do some test. Then need to test the hypothesis, understand and find there are variables. So what are the relationship of those variables, and those kind of thing we have to test in a research. Then the third one is replicability. So any research who did, and whoever going to do the one, it should be reproducible, or that data should be reproducible. Otherwise, that the research is not a good one. It means that the existing data may be manipulated, or so the data what we're going to publish, it should be reproducible. Then fourth one is objective. The data that is collected for research should be free from any bias and wasted interest. So someone can say, give some information to someone else to favor of that person. So that kind of thing we say it's biased information. So that kind of information should not be in our research. The other one is rigor. That can be defined as the criteria for the trustness of data collection and analysis and interpretation. So this one is related with objectivity. So the trustness of data should be there. So then that means the data is not manipulated. Right. Parsimony. So the parsimony. So that that should be, the research should be conducted in a simple and economic way. So many research going on. So if that if we spend more money and get a small data set, or that means that money is wasted. So we should first have a budget on before design the research work. So then we should do a research in an economical manner. So then that research going to be a good one, and it should be, the research should be generalizability. That means the research should focus on many people, not the very small group of people. So it should be useful for many people. That kind of research also can categorized as a good research. Right. So in a research, there are several steps. So first one is we have to identify a problem, and then we have to read on that problem, what kind of thing we had done before, and what kind of thing haven't done, and what are the difficulties. So the second part of the research is the literature review, and that is reading on the previous studies and what we can or get an idea about what we can do for our research. And by looking at the literature, we can design a research. So how we are going to do the research, what kind of instrument we are going to use, and how we going to do it, like a survey or like a lab work or any kind of thing. So design the research, and then after designing the research, we have to collect the data and then analyze the data. Then finally it should be published as a paper or report. So this is not exactly like a waterfall. So at some step we have to go back and refine the our research work. Sometimes it may be in a designing process. So maybe we may face some difficulties. So then we have to go back and get some, again, we have to do some literature review and come back to. So like there are some going back and refine those things, and finally we can make a good research work. So I will explain one by one. So first one is to identify the research problem. So research problem is a specific issue or difficulty or gap in knowledge that we will aim to address in our research. So for example, the one problem is fossil fuel will be finished within few decades based on current rate of consumption. So that means within few decades we will face a problem. That means we did not have, or we don't have any fuel to use for it may be for our vehicle or power generation, anything. So that's a problem identification. And to talking about the gaps in knowledge, so I had put one image in lower right corner. So it's the name of the forest is the dancing forest, and in Russia. So we know the trees are on floor and growing on the soil, and it's growing against the gravity. So normally what we see, the trees are vertically situated in our area. So but in the dancing forest, they are curved. So there are no explanation to that curved trees in that dancing forest. So we can do some research to fill that gap. So gap means we know that trees are growing against the gravity, but what happened in there, or why they curve. So likewise, we can get some knowledge about those kind of things. In a literature review, so it should be, we have to read more about the problem, and we have to identify what kind of thing done before and what kind of thing we can do. So for example, that in previous one, my problem is fossil fuels is going to finish. So by doing a literature review, we can identify there are some alternative fuel source or energy sources like hydropower, solar power. So we have to we can get those from literature review, and not from the sources, we can get an idea about what kind of hydropower plants are there, what kind of solar cells are there, so what are the drawbacks of them. So likewise, we can get the information by doing a literature review. How to now we know the problem and what kind of thing done before and what kind of thing we can do. So we have to design a research. Then to do that, first thing, the safety first. So we should do a research in safely, and the research framework should we are doing or we designing what kind of instrument we are using, what kind of chemical we are using. So to safety, first thing, if you're using an instrument, we have to it may be we have to use a safety goggles or something like that. And for a chemical, it's called data sheet. So we can read them and get an idea about what kind of chemical we are going to use. So actually that designing also in the part of a literature review. So when we're going to design and when we're going to use that chemical or instrument, again, we have to go back and read about those chemicals and instrument. So to get a idea about the chemicals, we should read MSDS, and we can get the information from previous research work. And if it is a chemical, we can ask from a chemist. Likewise, we can get some information and decide how we're going to do the research. Right. Then the collecting data, it is independing on the objective of the study and research design. Where we choose some instrument, what kind of data we're going to get, likewise, and the availability of time, money, and instrument. So, for example, in Corona pandemic situation, the research should be done in very fast. Otherwise, a lot of people will die. So it's a time depending one. So we cannot think about money. So we have to spend more money, but do the research within a very small time. So that's how we have to balance those money, time, and instrument. So then I would like to say, when collecting data, note down everything, what you expect, what you observe. So it will help when you're going to write your report or the paper. So sometimes some data, or it may be looks like a wrong values, but sometimes they may give a different aspect of the that research. So sometimes the misjudging or miscalculation of the in the lab, it can be a huge cost for the research team. but some researchers found the breakthrough principles by doing some mistakes. So that's why it's have to have note what we observe. So it may be a wrong data, but it may be that data will be open a new path for a new research. So by misjudging and miscalculation or by mistake, there are a lot of things has found. So for example, penicillin, plastic, the microwave, gunpowder, and anesthesia. So they discovered by mistakes in the research. So right. So when we after gathering the data, we have to sometimes we have to reduce the collection of data to manageable size. It may be that sometimes that computer may not handle that much large data. So sometimes we have to reduce those things, and then we have to get a pattern, and we have to apply statistical technique and understand and interpret what we finding. So I had put some graph here. So there belongs to impedance spectroscopy of it can be a material or anything. So the left figure, it show data points in spheres and fitted graph by line. So as we see that fitted line is not exactly on the data points. So sometimes we cannot actually fit the data, but we should fit the data to fit the curve to the data so that all the data point should cover the fitted data. Otherwise, that the fitted data is not correct one, that what we got from the actual data. And right hand side, I had in top, it shows the theoretical data or theoretical expectation. So the figure A shows impedance spectrum for a capacitor and a resistor in parallel, and it should be a perfect semicircle. And in the bottom, I had shown the actual data, and it's not exactly a semicircle, and there are some points in middle here and there. So it's not only on a semicircle. So that kind of point, sometimes we may need to data, not get a good semicircle. So sometimes it's give like a line or not a semicircle. So in that situation, we have to remove some points, and it may be that the point may be because of some errors in the our sample or a loose connection likewise. So we have to remove some one or two then fit into the expected theoretical curve. So then the most important thing is writing the report, and what we got from the research, it can be a good result or it may be a bad result, but we have to publish those things. So otherwise, the other people will not know about our findings, and they also going to do the same thing, but we already done, but we haven't published. So because of we haven't published, they didn't know that research is done by someone else. So it's to report on what we find, and we must make sure that most of the audience can have access that the report or a peer review journal. So I am going to share some of my experience on my about 10 years research work. So I had research assistant in National Institute of Fundamental Study in Kandy, and work in the lab solid state physics and solid state chemistry and condensed matter physics lab. So my supervisors are Professor Lakshman Disanayaka and Professor Rohan Senadira. So I, under guidance of them, I had done many research. So in that lab, we did the dye-sensitized solar cell. Categorize those my work in the steps of the research. So our problem is looking for a alternative energy source for electricity generation. So what we choose is solar cell, and there are many type of solar cell: silicon, thin film, dye-sensitized solar cell. So silicon solar cell, they give more efficiency, but the production cost is very high. Thin film, they are give good efficiency, somewhat low cost, but the material we use they are toxic. And the final one, what we did was going for a dye-sensitized solar cell. So the problem is in the dye-sensitized solar cell, they are cheaper. That means the production cost is low, and easy to manufacture, and they are not giving much efficiency. So what we going to do is increase the efficiency of dye-sensitized solar cell. So we have to design our research work to enhance the dye-sensitized solar cells. So dye-sensitized solar cell has 3 components: working electrode, that is photoanode, electrolyte, and count electrode. So in our lab, we have facilities do the research on photoanode and electrolyte. So in this case, what I chose was do a research on electrolyte. So normally what we do is we have to have a iodide ion electrolyte. So we use a single iodide ion salt like potassium iodide, tetrapropyl ammonium iodide. But many research has done on that kind of iodide salt, and the newest research was done for a 2 cation, or which can give 2 iodide ions to the electrolyte, so like magnesium iodide. So we had done prepared a new electrolyte using magnesium iodide, but the thing is efficiency than what we used in the lab, tetrapropyl ammonium iodide. So tetrapropyl ammonium iodide is a single iodide ion salt, and magnesium ion is the two iodide ion salt. So the tetrapropyl ammonium iodide give higher efficiency and magnesium iodide give low efficiency. So what we expect was disensel, but using the magnesium iodide, it give low efficiency. So then what we did was bring some electrolyte from A, that means only tetrapropyl ammonium iodide, and some electrolyte from E, only from magnesium iodide, and mix together. So it gives somewhat larger efficiency than the only magnesium iodide and only tetrapropyl ammonium iodide. So then my supervisor, he said, we cannot publish those kind of results because I never measure the what amount from A and what from amount from E electrolyte. So we have to do it in a meaningful way or the systematic way. So he suggests we have to do a series of electrolyte. So we then do a or make a series of electrolyte using or varying the magnesium iodide to tetrapropyl ammonium iodide, the weight ratios, and remarkably it gives the result that we got earlier, and it shows a good trend, and the mixture gave much higher much higher efficiency than only tetrapropyl and only magnesium iodide. So we published that result in a conference paper in 2011, Solar Asia 2011, and we haven't stopped from that one. So in this case, we had done only the measurement of or the IV measurement of the solar cell, and we published the data. So we haven't stopped from that one. Then the magnesium iodide one is a new salt for our group, and we had done many electrolyte using single cation iodide salt. So if that phenomena is a true one, that means to tetrapropyl ammonium iodide and magnesium iodide mixture, it should work for any kind of salt. So we are very common with that potassium iodide, that means single iodide salt. So what we did was we make a series with single iodide salt using potassium iodide and tetrapropyl ammonium iodide. And so in the first one, it is a liquid electrolyte, and this one is a gel electrolyte. So we make a gel electrolyte to overcome some of drawbacks in liquid electrolyte, like leakage problem. So in this case also, we found that the mixture of that two iodide salt will give higher efficiency than using a single iodide salt. So in this case, we did some conductivity measurement and DC polarization measurement to understand what is going on in there. So we found if we use a larger cation iodide salt and smaller cation iodide salt, it has two different phenomena. larger cation iodide salt give higher voltage value but less current value, and smaller cations give higher current but smaller VOC values. So both together in the middle of mixture, that means optimized ratio, it will give larger VOC and larger JC current. So this is the efficiency variation with the current and not so this is the gel electrolyte. So again we tested with the liquid electrolyte, so it's a true one. It should show to that liquid one also. So then the same thing we had observed in the liquid electrolyte, and we had published that result in Journal of Photochemistry and Photobiology journal. So we had introduced to the DSSC field so-called mixed cation effect, and we had explained how that the efficiency enhancement is can be happen. So after publishing this paper, it was in the top 25 list of most downloaded articles, and later we had did some research work on different kind of polymers and different kind of salt and different ratios. So we had a lot of publication in mixed cation effect, and we are the first one who discussed the mixed cation effect in dye-sensitized solar cell. So this is the end of my talk, and I would like to thank again Professor Sanath Gamage, President of the IPSL, and special thank goes to Chathuri Nupiyarachchi, co-editor IPSL. Thank you, and open for the discussion.
Thank you very much, Dr. Thotawatthage. It's time for the questions and comments. If you have any question, please feel free to ask.
Yes.
One question, I'm Rahubadha here. In fact, though we come up with innovations and inventions, so it will not make a real impact in the national economy in our country. In fact, we have the huge gap between the academia and the industry.
Yes.
So there are some institutions which needs to work on that. So are we, and I would like to know your view regarding that, the innovations, and what is the next, what can we do after the innovations?
Yes, it's a good question. So actually in our institute, we doing fundamental research. So now we trying to go for a applied research. That means what we finding, we are going for a commercializable thing. So there are some products from NIFS still we can find in the market. So still we are not got any chance to do some, to make some solar cells and in Sri Lanka. So in near future, I think we can go for that one.
Well, thank you so much.
Any more questions? So I have one question. What are the limitations that you have in order to develop this type of study in Sri Lanka? So
Actually, yes, the budget problem. So, into our institute, we got mostly for do the research. And as I said, there are some projects involving the productions. So new project is coming, and sooner they will we can buy those products from the market. And in our lab also we expect some fundings to do some go for a marketable thing. So that is they are the limitations of in our labs.
any more questions? If no more questions, I would like to thank today's speaker of our monthly webinar, Dr. Thotawatthage, especially for accepting our invitation and giving a very nice presentation. Thank Lord for it. And for the vote of thank, I would like to invite Dr. Rahubad, the Joint Secretary of IPSL. Over to Dr. Rahubad.
Thank you so much, sir. Today, Dr. C.A.Thotawatthage has successfully conducted the timely lecture titled on how to do an innovative research work. In fact, that was a supportive and helpful moment in updating our knowledge and understanding regarding the process of research and innovations. On behalf of our President of IPSL and Council members and all the members of IPSL, I would like to convey my sincere gratitude to Dr. C.A.Thotawatthage, and we all wish you all the very best. Thank you, my friends who work to make this event success, and all the audience. Good evening.
Thank you very much, Olo.
Thank you.